you do not understand parameter setting properly, you are taking a very high risk every day. Many motors burn because of poor quality, but many VFD trips not but because of internal damage. The real reason is wrong parameter configuration. Okay, and the dangerous part is most technicians they think how to set VFD. Okay, I'm again saying most technicians think they know how to set VFD. Okay, but they only change frequency and run. That is not parameter setting. Okay, so today I am going to explain everything slowly, step by step, like we are sitting together in plant during commissioning. Okay, this is not theory, this is a practical thinking. Okay, if you understand this video properly, you will become confident in VFD handling. Okay, so relax, focus, and let's begin. Okay, so first part is what happens when you install a new VFD. Okay, so imagine this situation. You receive a brand new VFD from supplier, you mount it in panel, you connect input supply, you connect motor output. Okay, now most people do, they power on it, they change frequency reference, and they press run. Then motor rotate, they feel successful, but they forgot something very important. The drive does not know motor yet. Okay, the only knows factory default values VFD. Okay, I'm again said that it is only know factory default values. Okay, factory settings are general, they are not customized. So every motor is different. It's different current, different speed, different load, different application. Okay, so first rule, never run motor on default setting. Okay, always configuration done. Okay, so now I will explain every critical thinking setting in depth. Okay, part 2 is rated current, motor rated current. This is the most important parameter. Let me explain. Okay, the VFD protect motor based on current value. Okay, if motor current increases above rated current level for long time, motor is overheat. Okay, drive monitor current continuously. Okay, but how will drive know what is rated? You must tell is, now think about two dangerous scenario. Scenario 1, most rated current is 10 ampere. Okay, but you enter at 6 ampere. Okay, so what happened? During normal operation, motor draws 8 ampere. Drive thinks this is overload and it's trip rapidly. Okay, you will think drive is faulty, but actually its parameter is wrong. Okay, and scenario 2, motor rated current is 10 ampere. Okay, but you enter 15 ampere. Okay, now motor overload at 12 amps. Okay, drive thinks this is normal because limit is high. Motor and continue running, heating increases. After some time, winding insulation weak. Then motor burn and you blame manufacturer. Okay, but the problem was wrong setting. So always stand near motor. Okay, read nameplate carefully, enter the correct value. Okay, double check it, do not assume, do not guess. Okay, this is a single step prevents many problems. Part number 3, acceleration time in. Okay, acceleration time in detail, I am saying that. Now we go deeper. Acceleration time means how fast motor reach the target speed. Okay, let me explain with example. Imagine a heavy conveyor carrying cement bags. Okay, heavy conveyor carrying cement bags. If you suddenly forced to reach full speed in 2 seconds, so what happens? If you suddenly force it to reach full speed in 2 seconds, so what happens? First, mechanical shock. Okay, belt tension increase, gearbox stress increase, motor demands high torque requires high current, drive detects overcurrent and trip. Now think differently. If you allow motor reach full speed in 15 to 20 seconds, okay, so what happen? It will smoothly increase, current remains control, mechanical parts are safe. So acceleration time is much application. Okay, so acceleration time is must match application. Okay, heavy load for longer acceleration, light load can be shorter. Okay, there is no fixed universal value. You must understand your load. Many technicians set 3 seconds because they are impatient. Okay, but proper setting saves equipment life. Okay. Part 4, declaration time with real industries. Okay, let me share a practical situation. In one plant, VFD was tripping every time operator stop motor. Okay, I'm again saying that. In one plant, VFD was tripping every time operator stop motor. Fault was overvoltage. Okay, technician replaced drive, still same problem happen. Finally, we check parameter and declaration time was very short, at least 1 second or 2 seconds. The motor had a heavy rotating load. When stopped quickly, motor acted light generator. Energy flow back to the drive. Voltage inside drive increase. Drive trip for protection. We simply increase declaration time and problem solved. No component change, no expensive replacement, just logic. So whenever you see overvoltage during stopping, check declaration first. Okay. Part number 5, control mode confusion. Okay. Many drives offer multiple control modes, but beginners get confused. They hear vector control and think it is advanced and better, so they select it blindly. But vector control requires a proper motor data. If data is wrong, performance becomes unstable. For simple pump or fan, basic control is sufficient. Do not complicate system unnecessarily. Okay. Choose mode according to application. Okay. Simple application, simple control. Okay. Complex application, advanced control. Okay. So part number 6, current limiting misuse. Okay. Now this topic is very serious. Okay. When drive trips due to overcurrent, many people increase current limit. This is very dangerous. It is like removing fuse because it is keeps blowing. Instead of solving overload, you increase protection limit. Eventually, motor will suffer. Always find root cause. If current high, so ask why. Is load is heavy? Is acceleration too short? Is mechanical system jam? Okay. Never hide problem by increasing limit. Part number 7 is maximum and maximum speed limit. Part number 7, maximum and maximum speed limit. Another overlooked setting, maximum frequency. If you allow the motor run beyond safe speed, mechanical damage can occur, okay, especially in pumps and fans. Minimum frequency also matter. If motor run too slow for a long time, cooling fan attached to shaft may not cool properly. Okay, I'm again saying that if motor run too slow for long time, cooling fan attached to shaft may not cool properly. Motor may overheat, so they reasonable speed limit. Think about mechanical safety, not just electrical. Okay. Part number 8, earthing and environment. Okay. Even perfect parameter setting cannot compensate for bad installation. Proper earthing is critical. Okay. Proper grounding causes noise, earth fault trips. Poor grounding cause noise, earth fault trips, damage to electronics. Panel cleanliness is also important. Dust block cooling, heat rise, drive trips on temperature. Many times solution is simple cleaning. Maintenance culture matter. Okay. Next, part number 9, professional troubleshooting mindset. When drive trips, do not panic. Follow logic. Read fault code. Understand meaning. Think about recent change. Did load change? Did operator adjust something? Did supply fluctuate? Troubleshooting is investigation, okay, not guessing. Do not randomly change any parameter. Change one thing at a time and observe. Okay, check manual. This make you perfect for professional. Okay. So my final conclusion is, if you remember only one thing from this video, remember thing, VFD is intelligent device, but it depend on information you give it. Okay, if you give correct motor data and reasonable setting, it's protect your system. If you ignore parameters, you create problem yourself. Do not fear VFD. Understanding it deeply. Okay, take time during commissioning and be patient. Think logically. That's why how you grow from advance. Okay, if this video help you, okay, so please like and subscribe my YouTube channel and comment. Okay, if you please comment your most common VFD issue. Okay, thank you very much. So before I end this season, I want to talk about something very important. Many people think learning VFD means memorizing parameter. Okay, but that is not true. Understanding VFD means understanding behavior. Let me explain what I mean. When VFD a trip, it is not random. It is reacting to something happening in the system. So instead of thinking why this drive bad, start thinking what is the thinkum trying to tell me. This is small shift in mindset, you change everything. Okay, so one of point I have added real industrial thinking. In real industrial thinking, machines do not operate in isolation. Motor is connected to load is connected to process, and process is connected to production demand. Okay, if production increases suddenly, load is increases. Okay, if raw material quality changes, load may be changed. If environment temperature increase, okay, so cooling efficiency reduce. If this factor influence motor and VFD behavior. Okay. So when troubleshooting, never look at VFD alone. Always look at the system. Always look at the full system. Okay. That is practical professional thinking. Okay. So why some technicians struggle with VFD? Okay, technician or a electrician, technician or a engineer, okay, site person, okay. So let me honest, many people struggle with VFD because they fear it. They think it is too electronic, too complicated. But actually VFD logic is very simple. If current high, protect. If voltage high, protect. If temperature high, protect. If leakage detected, protect. It is not mysteries, it is logical. When you remove your fear and apply the logic, it becomes easy. Confidence comes when understanding, not memorizing. Okay? And common behavior that cause problem. Okay, this is a topic. Common behavior that cause problem. There are some habits that create repeatedly fault. If you like my video, please like and subscribe my YouTube channel. I become engineer. Okay, continue. There are simple habits that create a repeated fault. Copying parameters from internet, increasing limit blindly, ignoring mechanical inspection, skipping earthing check, not documenting changes. Okay, let me explain the document. Whenever you change the parameter, write on it, because if problem worse, you must know what you changed. Professional engineer maintain the record. Okay, random adjustment create confusion. Okay, random people are adjustment create only confusion, not solution. Next point is long term damage versus short term fix. Okay, sometimes when VFD trips, production pressure is high. Supervisor say just make it run. Okay, so site person engineer increases current limit, drive run, production continue, everyone happy. But motor slowly overheat over weeks. Finally motor fail. This is short term fix but long term damage. Always think long term reliability, protect equipment that make you valuable professional. Okay, so how to grow from lower to expert. Okay, if you want to grow in career, you don't only learn which button to press, learn why you are pressing it. Ask question like why this parameter here, what happen if I change it, what is the risk. Okay, when you start thinking this, like, your understanding becomes deep. Okay, and supervisor trust, okay, who understand the logic. Okay, so building confidence message. Okay, I'm giving you build confidence message. If today you feel VFD is complicated, do not worry. Every expert was once confused. The difference is they kept learning, they observed fault carefully, they did not panic during fault. Stay calm, think logically, and you will master it. Okay, so my final last topic is what is today we discuss. Okay, so today we discuss why parameter setting is critical, how wrong setting cause motor damage, why acceleration and deceleration matter, why current limit should not be above. Okay, why earthing environment matter, and how think like professional troubleshooter. If we truly apply this knowledge, your plant problem will be reduced significantly. If this video help you, support this channel by subscribing and comment below what is the most common VFD fault you face in your plant. Okay, in next video I can take real fault scenarios and explain step by step solution. So thank you for watching till the end. stay safe, keep learning, and respect proper parameter setting. Okay, thank you very much. Please like and subscribe my YouTube channel. I become engineer. Okay.